It's probably that time in the video series where you're like, when are we going to use this again? And so I've conveniently plopped a link to some forum entries about that exact question. If you're curious and you need some inspiration, go ahead and read the blog. I'm not going to read it to you. You're welcome. Let's work on some more equations and getting comfortable with factoring and seeing it factoring, that is, when a does not equal 0. For exercise 3 or example 3a, we have 3x squared minus 16x minus 12 equals 0. And so I'm going to factor to two binomials. I'm going to do a 3x and an x. And then I'm going to try a 4 and a 3. This will give me a 9 and a 4, and that doesn't seem to work. So I'm going to swap these around. I'm going to do 4 on the outside and 3 on the inside. That worked? Nope, because now we have two 3's in the first binomial. So wrong factors. They're just not working at all. So let's try 6 and 2. 3 times 6 is 18. 2 would give me 16 if it was subtracting. So let's do negative 18 and positive 2. That will give me a negative 16x. Ta-da! So now we have to set those factors equal to 0. Do not forget that part. I've lost points on test myself for forgetting that last part. So 3x plus 2 equals 0, and x minus 6 equals 0. So that will give me 3x equals negative 2, and x equals negative 2/3. The other solution is x equals 6. In part B, I have 6x squared equals 13x plus 5. Let's set that equal to 0. That will give me 6x squared minus 13x minus 5 equals 0. Factoring, I will have a 2x and a 3x as my first terms in the binomial. And now, since 5 is negative and prime, I'm going to go ahead and try 5 and 1. If I look at that, I'll have a 10 and a 3. So if I do negative negative, I would get a negative 13. That's convenient, but I would have a positive last term. So let's rearrange these again. Let's go with 5 and 1 in the other order. That would give me a negative 15 on the inside and a positive 2x on the outside. If I added those together, I'd get a negative 13x as my middle term. So we'll go ahead and go with that set of binomials. Now I'll just set my binomial factors equal to 0. And then solve for x. X equals 5/2 and x equals negative 1/3. Now let's take a look at 8n to the third plus 10n to the second equals negative 3n. I'm going to rewrite it in descending order of exponents on one side of the equal sign. So we will have 8n cubed plus 10n squared plus 3n equals 0. Factoring out an n, I have 8n squared plus 10n plus 3 equals 0. Now I need to factor the trinomial. I'm going to go with 2 and 4, n and n. And I think I'm going to go with 3 and 1. Let's see what that does. That will give me a 12 and a 2. So the 12 has to be positive. No, that won't work. So let's try rearranging it. Let's put the 3 on the outside and the 1 on the inside. That will give me a 6 and a 4. Ah, there we go. Because all my terms in the trinomial are positive, so we'll have plus plus. That gives me n equals 0, 2n plus 1 equals 0, 4n plus 3 equals 0. And so then solving for n, I have n equals -1/2, n equals -3/4, and n equals 0. On this last equation here, I have an x I need to distribute. So I have 5x plus 12x squared minus 28, setting it equal to 0, equals 0. Now I need to write it in descending order of exponents. Then I need to factor it. I'm going to go with 4x and 3x. Can you tell that's my default? I always start with the numbers that are closest together for my factoring. And then, let's see, I could go with 2 and 14. 2 and 14. I could go with 4 and 7. I think I'm going to try that first. I'm going to go with 7 there and 4 here. So that'll be 16 versus 21. And that will have a difference of 5. I need the bigger number to be positive. So I need the 21 to be positive and the 16 to be negative. Now I need to set my factors equal to 0. And so my solutions will be x equals -7/4 and x equals 4/3. When is f of x equal to 0? Or what values of x provide f of x equal to 0? That's what that is asking for. So let's factor it. 2x squared minus 13x minus 7 equals 0. So we're replacing the f of x with 0. Now let's factor it. And we'll have a 2x and an x, a 7 and a 1. Let's see what happens. 2 and 1 is 2. 7 and 1 is 7. That won't give me a -13 in the middle. So I'm going to rearrange my 7. I'm going to put 7 on the right and 1 on the first binomial. That will give me 14 and 1. That will give me a 13 as long as the 14 is negative and the 1 is positive. Now I'm going to set my factors equal to 0 and solve for x. Those are my two solutions, x equals -1/2 and x equals 7. If we let g of x equal to 2x squared plus 5x, find a such that g of a equals 12. What is this asking? You need to think about what g of a is representing. G of a represents an output. So it's saying in place of g of x, write 12. And we need g of a to equal 2x squared plus 5x. Now instead of saying x, though, we've replaced it with an a here. So now we have 12 equals 2a squared plus 5a. 5a. Now I'm going to bring the 12 to the other side. So we'll have 0 is equal to 2a squared plus 5a minus 12. Now I need to factor this. 2a and a, 3 and 4. Let's give that a try. 2a squared, the outer will be 8 and the inner will be 3. As long as the 8 is positive and the 3 is negative, we have the factors we need. So we'll set 2a minus 3 equal to 0 and a plus 4 equal to 0. That will give me a is equal to 3/2 and a is equal to -4.